This video talks about area under the curve in the context of physics. And when we say area under the curve, what we really mean is if I had a graph, y of x, then it would have some shape. And I might wonder, what is the area below that shape or between that shape really and the x-axis? Well, that's this area. And we want to know how to calculate it. And so we're going to talk about the area under the curve as it relates to the three graph types that show up in kinematics and that I wanted you to know for this course. So let's look at the simplest case, the constant case, where our value is not changing with x. When we talk about area under the curve, we're going to talk about the area between 2 points. And so if I look at these 2 points, this first point has some x value, and this second point has some x value. And it is a distance c away from the x-axis. And so I can draw sort of a rectangle that makes between this green line and my x-axis. And then this shaded region then is the area under the curve. This is just my change in x, right? It's my final x minus my initial x. And the height of this rectangle, well, that's just c. That's just the distance between my x-axis and my line, which is c. And so my area is equal to c times the change in x. That should look awfully familiar to you. That's the area of a rectangle. Sometimes it's written base times height. Sometimes it's written length times width. It can be written in lots of different forms. Looking at the linear graph, we can talk about the area under the curve. If we pick 2 points, say this one and this one, you can see the region between that curve and the x-axis is this shaded region. Well, that's a triangle. And the area of a triangle is 1/2 the base times the height. So if we look at this, our change in x, this is our delta x again, that's our base. What's our height? Well, our height isn't delta y so much because there's not a constant delta y, but it is whatever the largest y value is between our 2 points. So the largest y value. And then to get our area, well, that is just delta x times that largest y value times 1/2, right? It's 1/2 base times height. So this is y max. 1/2 base times height. So we can get this from this area under the curve by just knowing the value of our function. An interesting thing happens though, because we said we don't, when we talk about area under the curve, we're not just talking about beneath the curve. What happens if I picked 2 different points? What happens if I pick this point and this point? Well, now, again, we don't want beneath the curve, we want between the curve and the x-axis. So now I have this region. Still, this is my delta x, but now my y max ends up being a negative number. And so my area ends up being a negative area. And if I had to add these 2 areas together to get the area between this point and this other point here, well, now I would have a positive area and a negative area, in which I would have to do the sum of the 2, right? So When we say, this is why I put quotes around under, because when we say under the curve, we really mean between the curve and the x-axis. If we went back to the constant graph and instead of being a straight line positive, it was instead a straight line negative, again, we might have 2 points, and those 2 points would give us a negative area. So be careful when calculating or when discussing the area under the curve. Don't get confused by the word under. For the quadratic graph, area under the curve is much more challenging. Sure, we could pick 2 points. We could, say, draw the region beneath the curve. We might be tempted to try out this region, where we draw this and just get this region in the box. But that's not the area under this graph, right? The area under this graph involves, there's the edge of my graph between those 2 points. And so the area under my graph is actually this whole region. Well, that's not a simple geometry. And so that's not something I would ever expect someone in the algebra-based class to be able to solve. If you're in the calculus-based class, of course, you should be able to solve this given the function of the curve. We could find the area, but it does require calculus. So if your class doesn't require calculus, then don't worry about this. You won't have to know it. So that concludes our discussion of area under the curve. As I said, it'll come up in the context of work and a few other topics in the course. When it comes up, we'll go through some examples, so don't stress out too much about it.